Okay, so again, guys, you're working on that warm-up independently. Okay, maybe about 1 more minute. All right. So looking back at that, the y-intercept is the value when x is 0. So we could find the y-intercept by plugging 0 in for x. So you get 9 squared minus 1. So that would make my y-intercept 8, which is this point right here. So that tells me this graph would continue and go through that point there. And then we also find our vertex, which is 3, negative 1, since this is in vertex 4. The axis of symmetry is x equals 3. Get our table of values, continue our points, God bless you. So once again, you would have seen that if we continued our table of values, it would have been 9 times 1, which was 9 minus 1, which also got you the y-intercept of 8. So 0.68 also exists on this graph. Okay? Questions at all on the warm-up? So what we're doing today is moving out of just graphing and into graphing with the addition of solving. So in order to know how to solve, you need to know what it means to solve a quadratic. So in order to know how to solve by graphing, you need to know in general what it means to solve. So that leads us to some definitions. The solutions of a quadratic are also known as the roots. call these the zeros when we're graphing it. We call these the zeros when we're graphing it. The ax squared is what makes it a quadratic. We refer to that as the quadratic term. Bx is the linear term, and c is the constant term. The highest exponent is 2. Therefore, we call this a degree 2. Okay. To solve a quadratic, you must have it set equal to 0. To solve a quadratic, it must be set equal to 0. And we're going to solve by graphing. So we're going to look at the points where the quadratic crosses the x-axis. To solve a quadratic, we set it equal to 0. And we're going to look for where the points cross the x-axis. Okay. So there are 3 types of solutions that we could possibly have when graphing a quadratic. Case 1 is no solution. That is when the quadratic does not cross the x-axis. So case 1 is no solution. That's when the quadratic does not cross the x-axis. Case 2 is one solution. That's when the vertex of the quadratic is on the x-axis. So when the vertex of the quadratic is on the x-axis, that gives one solution. Case 3 is when the graph crosses twice. That is 2 solutions. So case 3 is when the graph crosses twice, giving 2 solutions. So none, 1, and 2. So in the next example graph, that graph crosses twice. Therefore, you have 2 roots at -2 and 2. Another word for roots is x-intercepts. So in the past, I've asked you for the x-intercepts. So roots and x-intercepts are the same. We just write them a little different. The roots you write as x equals. The x-intercepts you write as coordinates. And we got those from the graph. So this has two solutions because it crosses the x-axis twice at -2 and 2. This graph also has two solutions because it crosses the x-axis twice at 0 and 2. So my x-intercept is 0, 0, and 2, 0. So it is important to be able to use the skill sets we attained in the last unit, which was to graph quadratics, because not always are we going to be given the graph of a quadratic. Sometimes we're going to be given the equation, and it is up to us to find the key points in order to get the graph. So the y-intercept is 0c. So in this case, the y-intercept is 0, 8. So I'm guaranteed on my graph the point 0, 8. I have to find the AOS by taking -b divided by 2a, which is -3. The vertex comes from plugging -3 in. So it's at -1. So that means that my graph has a point -3, -1. And then we use our table of values to find our remaining points. So it's x plus h ya plus k. So you do 0 minus 3, 1 minus 3, 2 minus 3, etc. So the x's always just go up by 1. I would hope if I could write that. I went 1, 2, 4. Should be 1, 2, 3, 4. And then the y's go by the perfect squares of the x's. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. In this case, everything's multiplied by 1, so they don't change. And then we're subtracting 1 from each of those to get my other point. So you get -1, 0, 3, 8, and 15. So when I plot those points, I have -3, -1, -2, 0, -1, 3, and then we already saw 0, 8, and then we have to graph its counter symmetric points. But our goal for this unit is to identify the roots, or the points where it crosses the x-axis. So in this case, it crosses at -2 and -4. So my roots are -4 and -2. Okay? 2x. So we have x squared plus 2x. So the y-intercept in this case is the +0 at the end. So my y-intercept is 0, 0. Axis of symmetry is -b divided by 2a. So -1. Plug in -1 to find k. So you get 1 squared minus 2, so you get -1. So my vertex is at -1, -1. So in that table, you have x minus 1, y minus 1. Then we get our values and plot our points. So we have -1, -1, 0, 0, 1, 3, 4, 8. And then our symmetric points gives -2, 0, -3, 3, -4, 8. And once again, looking for our roots, we get -2 and 0. Yeah. So it's just that A in this case was 1, and since my space is so teeny tiny, I just didn't write the ones. So the last example, remember I told you have to make sure your equation is set equal to 0. So currently that equation is set equal to 16. So you have two choices. You can move your graph to the right, or you can move your equation to the left. Personally, I don't like a negative on my x squared. So I'm moving my equation to the right. So it would be 0 equals x squared minus 8x plus 16. That way my x squared is positive. So when solving an equation like this without the y, our graphs can actually flip-flop each other. Some open up, some open down, but their roots are identical. So my y-intercept is 0, 16. My AOS is 4. So plugging 4 in, 4 squared is 16 minus 8 times 4 plus 16. Well, 8 times 4 is 32. 16 plus 16 is 32. So 32 minus 32 is 0. Oh, interesting. Okay. So it's x plus h, y plus k. So in this case, h is 4. Y is 1. And k is 0. The only reason I extended our table a little bit from before is because now sometimes the roots are a little bit higher. So you just need your table to make sure you see the roots. So we have our 0.40. Then it goes to 5, 1, 6, 4, and so on and so forth. So how many times does that graph hit the x-axis? It hits it once at 4. So this is a case of one solution because the vertex is on the x-axis. So it's a case of one solution because the vertex is on the x-axis. So your note packets are in a little different order for today because I had to staple them myself. So the next page in your notes packet is actually tomorrow's notes. So turn one more page in that note packet, and your homework should have 6 graphs on the front of it. So all you're doing on those 6 graphs is telling me how many solutions and where. So how many and where, and then on the back you're graphing those 4 equations. So how many and where for the front, and then you're doing the graphs on the back, just like we did 3 graphs in our notes today. Is everybody good? Yes. Correct. If it's a solution, there's no coordinates to get.